Hello everyone. Let us do one numerical problem today with respect to volume integral of charge density. So let us read the question. Find the total charge contained in a 2 centimeter length as shown in the figure. When we look at the figure, there is a volume of cylinder given where radius is still 1 centimeter and the cylinder is a complete cylinder of 0 to 2 pi angle and Z extends from 2 centimeter to 4 centimeter. The charge density, that means how much of charge is there in per unit volume, is given as minus 5 into exponential to the power of minus 10 power 5 rho Z microcoulomb per meter cube. So we should find how much of total charge will be present in this region if this is the volume charge density. We can write the charge enclosed or the total charge formula. Q total can be written as volume integration of this charge density rho v. Now this is a cylindrical coordinate system. We should know what is the volume element in cylindrical system, which is rho, d rho, d phi, dz, and we can give the limits from the given volume. That is, rho changes from 0 to 1 centimeter. We can write 1 centimeter as 0.01 meter. So I should write 0.01. And phi vary from 0 to 2 pi. Z varies from 2 centimeter to 4 centimeter. So that should be written as 0.02 to 0.04. We should take this expression for rho v and do volume integration to get the total charge. We can proceed with the volume integration. So I will start doing the integration. Q total is equal to triple integral of rho v, which is minus 5 exponential to the power of minus 10 power 5 rho z. Micro, I will finally write micro as 10 power minus 6. And dv element, this dv element should be written, which is rho, d phi, dz. You have to apply the limits for rho, phi, and z. This triple integral has to be evaluated first, taking one variable and integrate, apply the limits, will give the integral value for that variable. Then we can perform integration for phi, then we can perform integration for z. So when you look at this expression, it has rho multiplied with exponential term. So this is quite tricky to do integration when we begin with the variable rho. I'll begin with the variable phi first because there is no phi variable except d phi. So we can do that integration first and apply the limits for variable phi, then proceed to the other variables. So the other integrations, rho and z, I'm keeping as it is. That is minus 5 e power minus 10 power 5 rho z, rho, dz, I'm keeping as it is. I will first do integration for phi, integration d phi, and the entire thing has micro unit, so it is 10 power minus 6. This phi limits will be taken from 0 to 2 pi. Here, when we perform integration, it is required to use the angle for phi in radians. So let me do integration for phi first, which will give integration d phi will give phi, and when we apply the limits, you'll get 2 pi as the answer. So in place of this, I can replace 2 pi. So we'll have z and rho integration minus 5 e power minus 10 power 5 rho z, rho, dz into 2 pi into 10 power minus 6. I can take this constant values outside for our convenience. So these values minus 5 and 2 pi into 10 power minus 6, these are all constants. I can take it outside. So minus 5 into 2 pi into 10 power minus 6. I'll take it outside. Then integration for rho, let us do later. We will do integration for z first. So I'll write rho d rho. I will perform integration with respect to z variable. So this function has z variable dz. Let us integrate with respect to z first and then come to rho. When we do the integration with respect to z first, this z variable will be eliminated after applying the limits, and it will be easy to integrate with respect to rho. So let me do integration for z now. So integration e power minus 10 power 5 rho z dz, and the limits for z is from 2 centimeter to 4 centimeter. So it is 0.02 to 0.04. After doing this, we can come back to rho integration because this expression has rho in itself. After applying the limits, only z will be eliminated. Rho will be there remaining as it is. With that variable rho, we have to perform integration for rho. So let us do that. So this minus 5 into 2 pi, I can write minus 10 pi into 10 power minus 6. Rho is changing from 0 to 0.01 rho d rho. Then this has to be integrated with respect to z. So exponential of function of z is same, e power minus 10 power 5 rho z divided by minus 10 power 5 rho z. This is the integration of this. So I can give the integration formula. Integration e power az dz will be equal to e power az divided by a. So this is how the integration should be done for this function. Now applying the limits, the lower limit is 0.02, upper limit is 0.04. So we should do application of limits. 0 multiplied with, so here denominator should have only rho. So what I will do, this rho I can bring it outside. I'll get 1 by rho here, which will cancel these two rho terms. You'll have 10 power 5. So that 10 power 5 also I can bring it to numerator to give me 10 power minus 5. I can write it together here. 1 10 power minus 5 is there here in multiplication. Another one negative sign is there, so the negative sign I'm cancelling. So you will have e power minus 10 power 5 rho into 0.02 minus e power minus 10 power 5 rho into 0. First is 0.04, next we'll have 0.02. So this is after applying limits for z. Now we should perform integration with respect to rho. So 10, this can be taken as 10 power minus 10 5 into integration. You have two terms, e power minus 10 power 5 into 0.04. So I can write 10 power 5 into 0.04. This will be 4000 rho, and second term is e power. This will be 2000 rho minus 2000 rho. This has to be integrated with respect to rho with limits of rho from 0.0 to 0.01. Then we should do the integration. So you'll get 10 power minus 10 pi into first integration will give e power minus 4000 rho divided by minus 4000, and second term is e power minus 2000 rho divided by minus 2000, limits 0.012. Next, we can continue this, which is 10 power minus 10 pi into applying the upper limit and lower limit. These two should be applied to give four terms: e power minus 4000 into 0.01 divided by minus 4000 minus exponential to the power of 0, e power 0 divided by minus 4000, then lower limit, sorry, second term minus e power minus 2000 into 0.01 divided by minus 1000, then minus of minus plus e power 0 divided by minus 2000. Now we should compute using calculator to solve this. Before that, I can simplify this expression and put it in the calculator. So you'll get minus 1 by 4000 times e power minus 40 minus e power 0, this is 1. Then second term minus 1 by 2000 into minus e power minus 20 plus 1. So we can put it in the calculator, compute, and get the answer. So I will have pi into 10 power minus 10 into first term minus 1 by 4000 multiplied with, so I'll put one multiplication symbol, exponential, so e power minus 40 minus 1 minus 1 by 2000 into minus e power minus 20 plus 1. So you are having I can give minus 78.5398 into 10 power minus 15, or I can give minus 0.007853 pico. So let me give in the units of picocoulomb, that is minus 0.01 0.07853 into 10 power minus 12 coulomb, or you can write this as 0.07853 picocoulomb. So this is the total charge.